Okay, so quiet down please. So I'm making this recording for my juniors who are out all testing today so that they can know what homework questions we go over in class. So go ahead and tell me what questions you had on
20 last one, 36.
Okay, let's slow down.
And there were only 6 questions.
Yeah, there are only 6 questions. So 24 I heard.
36.
36. Okay. Are those the two main ones?
No, let's do more.
Okay, 35 and 36 are the same.
23.
Okay, do you have 23 also?
Yeah, I didn't.
How about, can we do like...
Okay, alright.
Wait, we don't have to do 24, we did that one in class yesterday.
24 was the actual problem we did in class yesterday.
Yeah.
I mean, I think it's the same numbers.
It was the same number, we don't have to.
I just need to rewatch that
Could you
lesson.
answer 5?
Okay,
13.
good. Alright. Yes, go
Hey,
ahead.
I'm not failing.
Oh, no. Okay.
That's nice, I'm passing this class.
That's
I
good.
know.
I'm almost passing. I'm getting there. I am, I'm getting there.
It's like passing skills. I passed the class on paper.
Okay, so 23. Quiet down, please. Alright, so we're being recorded. Quiet down, first period. Yes, this is going on the internet for all to see. So, at a sand and gravel plant, sand is falling off a conveyor onto a conical pile at a rate of 10 cubic feet per minute. So this is number 23. We have a cone. I'm just going to draw it as a triangle. It's always easier if you just keep cones triangles. Okay? So, the sand is falling off of some sort of a belt, and it's just falling into this pile, and it's forming a cone, right? Kind of a cone-shaped pile of sand. So, it's falling at a rate of 10 cubic feet per minute. What is that 10? What represents the 10? D what? How do you know that's dV dt? Because of the units, right? So dV dt is it positive 10 or negative 10?
Positive 10.
Positive 10, why?
The pile's growing.
Because the pile's getting bigger, right? Okay. Alright, the diameter of the base of the cone is approximately 3 times the altitude. So, by altitude, that's just fancy talk for height, right?
Yeah.
Okay, so if the diameter is this distance right here, then we're given that the diameter is 3 times the height. At what rate is the height of the pile changing? So what are we looking for?
DHDT.
DHDT. When the pile is 15 feet high, when h equals 15. Alright, so we've written what we're given, we've written what we're trying to find, we need an equation that relates the variables.
The volume of a cone.
Volume of a cone, right? So volume of a cone is 1/3 pi r squared h. So we know dV dt. We want dH dt. Do we know dr dt?
No.
No. And we don't want to know. We aren't given and we don't want it. So we've got to get rid of the r. Is there information in this problem that's just been handed to us that can help us get rid of the r?
Yeah, we have a diameter. Can't you just multiply it by 2?
Right. Diameter is the same thing as 2r, right? So we know that 2r equals 3h. So r is 3/2 h. Does that make sense?
Yeah.
That was just given to you. It's like, here's a present, right? So we're going to replace the r with 3/2 h. When you do this, please make sure that you square both the number and the letter, right? So 3/2 squared is 9/4, and then h squared times h is h cubed. If you want to clean it up a little bit before you differentiate, you can cancel a 3 and you get 3/4 pi h cubed. So that's a nice simple formula, right? Okay. Did you have a question? Okay. So now we take the derivative with respect to time. So the derivative of v is dV dt. And you can multiply the 3 or you can keep the coefficient and then just do times. What's the derivative of h cubed?
3h squared.
3h squared
dH
dh dt. Don't forget, every single derivative that you take in this unit will have a d something dt next to it. Right? Every single time you differentiate a variable, it's going to have d something dt. Yes?
Okay, so just like backing up, 'cause,
Sure.
like I don't really, I mean I understand that we don't need the R kind of. Can you just like explain that more?
Okay, here's why. If we were to differentiate this equation as it is, let's just pretend for a second, all right? So we get dv dt, and you can do this. I've had problems before where I gave you dr dt and dh dt, and you just had to differentiate this thing, right? So we have, what rule has to be used for this? Product rule, right? So anyway, so you get 2/3 pi r dr dt times h plus 1/3 pi r squared dh dt, right? So you get this for your derivative. All right, the problem is when we plug in, we're going to plug in a 10 for dv dt. We can figure out r, we can figure out h, we can figure out r. We want dh dt, but this dr dt, we don't know what to do with it, right? We don't have a dr dt, we don't know it. Now, what you could do, if you wanted to, say you accidentally went this route, you can substitute here. Like if you know r is 3/2 h, then dr dt is 3/2 dh dt, and you can substitute dr dt with 3/2 dh dt right here. And you'll still be correct. And I have seen students do that successfully. Not very often, but it happens. The problem isn't the substituting, the problem is the product rule, really, right? Yeah. So anyway, but I have seen people do that. So you don't have to substitute at the beginning. You can substitute at the end, but either way, you're going to have to get rid of that dr dt somehow. So it's easier if you just get rid of it at the beginning.
You just knew that R equals D.
We were given in the problem, the diameter was 3 times the height. And diameter is 2r, right? Right? A radius is...
Oh. Yes.
Ah! There's the key. Okay, good. All right, so now we just plug in. So dv dt is 10 equals 3/4 pi times 3 times 15 squared dh dt. And for your quiz tomorrow, there's no calculators, but I have decided on your test I'm going to let you use a calculator. Just in case you need that little kind of security blanket type feeling. So anyway, so whatever that all is, you work that out. And then the units, the volume is in cubic feet per minute. So what would dh dt be measured in? Feet per minute.
Okay, from the bottom, how did you go to the back?
Oh, from here to here? Solving for dh dt.
Okay.
So just times by 4 and divide by 3 and divide by pi and divide by 3 and divide by 15 squared. Yeah. Just moving all these numbers over to the other side. Yeah. Anyway, yeah. Are there questions on 23?
For the quiz, would we
So is that
be able to leave it like that?
Oh yeah, you can leave, even on the AP exam, you can leave answers like this. Yeah, as long as it's numerically equivalent to correct, it's correct. All right? Okay. 36. Shadow length. This is an important one. Do you guys mind if we do 35?
No.
Okay.
Yeah.
And then I'll also do 36 if you want, but 35 is what you're going to see today, so I thought it would be helpful. All right, so here we go. So we have a man and a street light. So we have a street light and we have a man. And the street light is 15 feet high. and the man is 6 feet tall. Now, I'm labeling these with numbers and not variables. Why?
Because they're given, they're constant.
Because they're constant, right? The light is not going to change its height, and the man is hopefully not going to change his height, right? Okay, so we have this light, it's beaming down, and it's creating a kind of a shadow for the man, right? Okay.
This is weird.
All right. Now, the man is walking at a rate of 5 feet per second away from the light. When he is 10 feet from the base of the light, at what rate is the tip of his shadow moving, and at what rate is the length of his shadow changing? Now, I personally like to do part B first. The way I have over the years become comfortable with approaching these problems makes it easier for me to do the second part first. So when I ask this problem today on your little practice thing, I do the second part first. I put the second part first. So part B in this homework is part A on your sheet. Okay? So anyway, so what I'm going to do first is find the rate at which the length of the shadow is changing, right? So I'm going to call this distance A and this distance B, right? From A is from here to here, and then B is from here to here.
What's the whole distance? C?
Sure.
Awesome.
Okay. Okay.
Yeah, that'll be better.
Okay. So we have this. We want we're given one thing and we want one thing. So we're given a couple things. So the first thing we're given is that the man is walking at a rate of 5 feet per second. Which variable, what would represent the rate that the man is walking?
D something DT.
You're right. D something DT
Stuff.
is 5.
Let's go with A.
Is DADT. Because here's the man, right?
Yes.
And he's walking. The rate that he's walking has nothing to do with his shadow, right? It's just the man. Here's a light post, here's a man, he's walking. It's the rate of change of A. Right? Whenever you're talking about how fast something is moving, it's always, if you have a fixed object and that item, say it's a car, right? Okay? The speed that the car is going is the same as the speed that this distance between the car and a fixed object is changing, right?
Yes.
This
Okay.
And it's
I think I
positive
got
5
stuck up, like trying to figure out which variable was changing as he moved.
Right. Because his moving has nothing to, even if he didn't have a shadow, his rate would still be DADT, right?
Yeah.
Okay. Shadows are relevant to how fast the man is walking. Okay. So DADT is 5, and it's positive 5 because A is getting bigger, right?
Yes.
Okay. Now, the question is, at what rate, oh, first, when he is 10 feet from the base of the light. So what's 10?
10 is
A.
A, right? That's how far the man is from the base of the light.
so it's always 10?
No, this is
No,
just
that was
at this
10.
moment in time. It can't always be 10. He's not standing still, he's moving, right? Okay. Part B first. At what rate is the length of his shadow changing?
So B.
DBDT is what we're looking for. That's what we're looking for. Because that's the length of his shadow. Okay?
This should just be an answer because after that I didn't sign make on there.
Well, this is real important that you understand this. Are you with me or are you
Yes,
really lost?
Kind of. It's like I'm like 62% with you. Hey, that's like more than half percent.
All right.
With you when you really explain it.
Okay.
Just keep going. You got it.
Tell me this. Looking at the picture and thinking about what we talked about yesterday with the cone problem. There's a similar concept in here.
Transversal.
What's
And
like
I-
a light?
There's
Transversal.
similar
Angle.
There is a similar
shape.
concept in here.
I see
It's just like a
that
smaller
word.
triangle.
Because you can't
Yeah.
cross a scalar and a vector. Is that right?
Okay, so do you all see that we have a kind of a little triangle
And then a mom triangle.
and then like a great big triangle,
Oh, I get it
right?
because the little
Okay.
triangle's inside the
Proportions.
little triangle.
Yes, and they both have right angles, like the man is hopefully standing up tall, right? He's standing up straight, the light post is straight. They both have right angles and they both share that angle, right?
True.
So these are similar triangles. Is that okay?
Yes.
Because they're similar, their side lengths are proportional, right? So we can write a proportion. I want you guys to take a second and follow me with this. 6 to B equals 15 to what?
A plus
To
B.
10.
To
A plus B.
10 plus B.
Oh, yeah, that's right. Yeah, 10 plus B.
Really, 10
Yeah,
is constant? Are we
No,
putting in a
10
constant?
No, but at that
What?
point, that's what we're asking constant,
What?
right?
At this instantaneous moment that we're trying to solve for,
Are we
is-
putting in a constant
Why
for
would-
something that's not constant?
Well,
Oh my god.
Well, it's constant at this time.
It's not constant at this time. He's
but I thought that's what we're asking.
so then A plus B.
No, but.
A plus B. We never plug in a constant for something that's a changing value until after we differentiate. Ever. Ever.
Exactly what I said.
Okay.
What I said.
Okay.
The words are out of my mouth.
Okay.
So 6A plus 6B
Okay, I get it.
So
equals-
now, do you guys all see how we got the proportions? Okay, I want y'all to solve this. Cross multiply. Maybe combine a couple like terms and then differentiate with respect to t.
This is the equivalent.
You're gonna be shocked at how simple this problem is.
This price. So I did part D in that today.
Okay.
Is there a way, like if it just asks for part A,
Wait, which
to
one?
go back and find B?
Yes.
What the heck?
You're trying to find
Yes, I'd have to really, I have to think about it, though, draw it out, to figure out how to squeeze it.
I just feel like I wouldn't be able to, like, I understand the concept, I just like the similar triangles thing and like knowing that you
Isaiah,
I'll tell you this, okay, Siobhan, before you read it, okay?
Okay.
The questions I'm going to
Now
ask
do the
you
rings.
on your quiz and your test
nothing that I didn't do.
will all
Okay, that
be of familiar types.
Alright.
So there aren't that many types for you to have to learn about, okay? So as long as you learn a general strategy for, you know, for a number, maybe 5, 6 different problems,
Then I will pass.
you'll be fine. Yeah, I don't like how. Well, watch how simple this is. Watch.
Like, it was really similar, it's just slightly different. Like, I got an equation almost identical.
That is a difference.
What's going on over here?
Oh, yeah, they differentiate from there.
Okay, I got that part.
30.
I don't.
Yeah, I got it.
30 over 9.
Okay, how did you guys do so far?
Golden.
Golden? Good.
Why can't you say A equals 3B? And then divide over
Where do you get
Like
A?
divide out the 3. Like.
You mean 2A equals 3B?
Oh, yeah. Well, yeah.
Okay.
And you could do that.
Alright, so we get, yeah, you can do that. Okay, so we have 6 times 5 equals 9 dB dt. So dB dt is 30 over 9 or 10 over 3, right? Okay, so, and if you, again, I promise you, just don't even bother reducing the fraction. If you make silly mistakes, then don't make them by not, just avoid doing them, right? Just let yourself be unsimplified. It's okay. Now, the units for this is the rate at which the length of his shadow is changing. He's walking at a rate of 5 feet per second. So what is this?
It's shrinking.
Still feet per second.
Shouldn't it be shrinking though?
No. The further he gets, the longer the shadow gets. Yeah. Think about it. As he gets further away, right, he's still 6 feet, right? The shadow gets longer and longer. The further you get from light source, the longer the angle.
Yes.
It really is getting longer. I can't, I'm not drawing it well, but it
No,
really is.
I'm
Okay. If he gets shorter, the shadow gets shorter, right? Yeah. Closer, if he gets closer.
Because the light's not just coming at that angle.
Alright, so now,
Actually, so
Yes.
it takes you to find a proportion to be able to get the equation.
yes, you need to set up a proportion.
Okay.
So for shadow problems, proportion is the way to go. Okay, now we're gonna do part A. Part A says, at what rate is the tip of his shadow moving? Now remember, when we want to know how fast something is moving, the easiest way to figure it out is to find the distance between that thing and a fixed object and find the rate of change of that distance. Does that make sense? Okay, so you can call it the distance a plus b and do dA plus b dt, and that would be okay, but that gets confusing for some people. So Tyler, what did you want us to call the whole distance?
C.
Let's call it c.
Yay.
Yay!
So we want the rate of change that the tip of the shadow is moving, so what would represent that?
Let's go with DC over DT.
dc dt.
Yeah.
You need the distance between the tip of the shadow and a fixed object, like the light post.
Yeah, wait, what?
Okay? So if we want the rate at which this dot is moving, we need to measure the distance between the light post and the dot and find that rate of change.
That's fine.
Now you could, if you wanted, and I think this is the way you circumvent, but oh no, it's not. But anyway, you could just do, this would also be very simple. It should be dA dt plus dB dt, right? So it should just be both of those. So let's just kind of do a quick proportion and just see. But it should just be dA dt plus dB dt. So let's just check. So if we want dC dt, again, I'm going to do a quick proportion. 6 over b equals 15 over c. Okay, so I have 6c equals 15b. So 6 dc dt equals 15 dB dt. And dc dt equals 15 sixths times 10 thirds, because that's dB dt. Yes?
How would you have done this one without doing B first?
That's what I was just asked a minute ago. I have to think about it for a minute.
Okay.
Probably not on film.
Okay, that's fine.
Yes, yeah.
We're all
So-
looking
Quiet on the
Yeah.
side.
So that, let's just clean it up, cancel that, make it 3, make it a 5. So I get 25 thirds feet per second,
Yeah, that's the same as dA plus dB.
and that is dA dt plus dB dt, so you have 10, which is, oh wait, where's dA dt?
5.
5, yeah. 5, which is 15 thirds plus 10 thirds, 25 thirds, right? So you could just do dA dt plus dB dt, which is 5 plus 10 thirds, and get dC dt.
I have a question.
Yeah,
With the proportion, how do you know what to put under it? Because that's a.
how do you know like what to set it under? Well, it's always like corresponding sides. You can do, like when you're writing proportions, if you think this side of this triangle to this side of this triangle, this side goes across from that side, right? And then this length corresponds to that side on the big triangle, right? You could also do it like this. You could say 6 to 15, 6 to 15 corresponds with B to C.
Oh, so we could have done 15 over C in the first part of the problem too.
Oh, like on part A or part B,
Yeah.
this part? Yeah, but the problem is if you use C DC here, you don't know DC/DT,
Oh, okay.
and so it gets to be kind of confusing. So I prefer to use A plus B in the first part because you don't know DC/DT, that's what you have to find in the other part. So, yes.
Why didn't you do part A first?
Okay.
Or like, could you do?
Let's just turn off the camera now because that's enough that the juniors need to know.